Hello and welcome to the Rashmi's classes. Today we'll discuss on the topic 5G Nr Key Enabling Technologies. So let's get started. Before providing our point of view on various challenges and solutions around planning and optimization, in this section, we shall discuss more on various key enabling technologies that are available within 5G radio services to meet the customer demands and support the above listed challenges that arise from use cases like eMBB, mMTC, and uRLLC. Millimeter wave communications. Traditional cellular networks use frequencies from 300 MHz to 3 GHz. Due to a higher wavelength, signals can be transmitted to several kilometers without significant loss. The penetration loss also is less and it is suitable for better indoor coverage in a sub-mm wave band. However, with the higher data demands, relying only on the spectrum below 3 GHz is not feasible to deliver eMBB services, which requires up to 10 gigabits per second. 5G, with its potential to provide higher capacity, is exploring the opportunity to use the spectrum above 3 GHz, mainly the wave range, 30 GHz to 300 GHz. Massive MIMO. Massive multiple input, multiple output, MIMO, is a key component in 5G new radio deployment. Each base station is equipped with multiple numbers of antennas transmitting concurrently using the same time frequency resources. 5G is using the higher frequency bands with a shorter wavelength. Based on the below formula, when the wavelength reduces, the received signal power also reduces significantly. The transmitter and receiver antenna gain should be increased to overcome this issue. Increasing the number of transmitters and receiver antennas is the practical solution to increase the gain. So MIMO is playing a major role in 5G to improve received signal power. 3D beamforming. Beamforming is a spatial signal processing technique with antenna array for directional signal transmission and reception by intentionally controlling the phase and relative amplitude on the same signal at each antenna. Contemporary multi-antenna base stations for cellular communications are equipped with 2 to 8 antennas which are deployed horizontally and are capable of steering beams in 2D. If we instead deploy multiple uniform liner arrays on top of each other, it is possible to control both the azimuth and elevation angle of a beam. This is called 3D beamforming. With a massive number of antennas, beamforming creates beams both vertically and horizontally towards the user. The major advantages of 3D beamforming is increased data rate and capacity, less intercell and intersector interference, higher energy efficiency, improved coverage and increased spectral efficiency. Frame structure. Different subcarrier spacing is introduced in the 5G NR system to accommodate large bandwidths in wave. The postulate introduces scalable orthogonal frequency division multiplexing, OFDM, subcarrier spacing and cyclic prefix durations based on carrier frequency and bandwidth. The increase in subcarrier spacing shortens the subframe duration. Thanks for watching the video. Please like, share and subscribe our channel. Rashmi's classes.